Welcome to the European CCUS webinar series. Today you'll hear about CCUS in Denmark. My name is Karina Søgaard and I'm the director of INNO-CCUS. And joining me is Henrik Sulsbrück, who is head of division for the CCS Danish Energy Agency. And I also have brought Jan Boyesen, who's the market director for CCUS at the Danish Technological Institute. So you'll first hear from Henrik Sulsbrück. He will tell you about everything going on the policy and regulation side. After his presentation, we'll take questions for Henrik immediately, since he has to leave at 10:25, 11:25, depending on your time zone. After that, I will give you a presentation on research and innovation on CCUS in Denmark and how we work in a mission-driven way. And finally, Jan will tell you about some of the implementation and give you some case story insights. So I look very much forward to this. I see we have more than 100 people joining. It's amazing that you are curious about this topic. And I think we should get started and give Henrik the floor so we can hear about the acceleration that has happened. So Henrik, please share your screen.
First of all, thank you very much for the invitation from the UK CCS to join this webinar. As Karina said, my name is Henrik Sulsbrück and I'm heading up the CCS division at the Danish Energy Agency. We are part of the Ministry of Climate, Energy and Utilities in Denmark and are sort of one of the sole responsible agencies, state agencies for CCS in Denmark. I have put together a few slides on the CCS status in Denmark, and I realized that I jumped straight into the implementation, but I think that's a very good picture of how we have worked with CCS in Denmark over the last 5 years. And obviously the reason for why we work with CCS in Denmark is the climate ambitions and the greenhouse gas reductions ambitions that we have in Denmark, where the politicians actually exactly 5 years ago for the first time sort of stated that we need carbon capture and storage in Denmark in order to reach our climate goals. That goes hand in hand with the initiatives on renewable energy, on energy efficiency, and all the other aspects that are well known across Europe and the globe for reducing greenhouse gas emissions. So the focus of the Danish CCS initiatives and implementation has been on sort of 3 pillars, at least also from which is sort of reflected in the work that we do in the Danish Energy Agency. Those 3 pillars are listed here and are supplemented very well by the stuff you will hear from Karina and Jan afterwards on the technology and concrete projects and what the research community is also doing within CCS in Denmark, which is a key enabler along the stuff that we do sort of at the ministry and the agency. Obviously, the 3 pillars that we have in Denmark are sort of a funding element, a regulation element, and a CO2 storage part. If you work with CCS, you are aware that there are no sort of viable business case for CCS at the moment in Europe, and that's also the case in Denmark. So what the politicians in Denmark have sort of identified is that we need to support the establishment of a market. We do that by a state aid approach in Denmark, and I'll put some details to that on that later. And then we have increased CO2 taxes and emission taxes in Denmark, sort of to increase the cost of emitting CO2, and at the same time, with the other hand, help industry implementing CCS. So that's the funding part of what we do. Then we have a more sort of a normal state agency role in terms of regulation. Obviously, a lot of the relevant regulation in Denmark is is not made or necessarily suited for CO2 handling, let it be capture, transport, utilization, or storage. So we have, over the last couple of years, looked at ensuring the adequate legal framework, provide an overview of what is required, and in cases we find barriers, also look at, okay, how do we remove them? And that has been a beautiful balance, or at least a striking a balance between the need for regulation versus the time. Then the last aspect is that we in Denmark are fortunate with a suitable geology for CO2 storage. So the politicians have seen that as a strategic asset, and we've done a lot of work in terms of maturing that. So that is what I will dive into the details on over the next 5-10 minutes here. So in terms of regulation, the approach that we have had in Denmark from the early days in 2020 is to use what we have in a way that gives the enough security for the market, for actors to start doing work in CCS, but also sort of balancing the public concerns that might be. And obviously the prerequisite for doing CCS in Denmark is that it has to be safe and environmentally in order, so that we don't harm the environment or harm any people on the way of trying to solve a climate issue. That has been sort of, for example, in the way that we handle the CO2 storage in Denmark. I'll put a little bit of more words on that later. Is based on our Subsoil Act, which has primarily been focused on oil and gas production and geothermal projects, but also has implemented the CCS directive in 2012, I think they finally implemented it, but never used it in Denmark. So that's sort of the approach that we have. Okay, we use the regulation that we have, but and that has brought us a long way. But we also seen requirements for clarity on some of the regulatory framework. So we have designed and implemented and agreed on, the politicians have a completely new act on CO2 pipeline infrastructure, a completely new act on CO2 capture activities in the utility sector, and an executive order on safety related to CO2 pipeline infrastructure. And you can say the second of these acts on CO2 capture activities is quite specific for Denmark, since most of the sort of primary sources of CO2 capture in Denmark, or a lot of them in the waste to energy sector, is in the waste to energy sector, and a lot of these waste to energy plants are owned by communities or cities, and they are on a quite strict regulation in terms of what activities can they endeavor on. And so then we needed a CO2 capture activity act for them in order to be able to engage in this on to some extent equal terms with the private companies that are some of the other major emitters in Denmark. Cement factory, some biomass thermal power plants, which are sort of the other primary emitters, alongside few refineries and biogas upgrading companies. On the regulation part, we also spent a lot of time on getting the cross agency collaboration. So a lot of the other state agencies are not familiar with CCS, so we spent a lot of time on that. And the approach has also been a very keen eye on what we need to have to get the market up and running, and what could be nice to have. And there's probably still a bunch of nice to have, maybe even a few need to have that we need to look at for the coming years. The whole aspect of what we're trying to do is to establish a CCS market in Denmark that can stand on its own without public funding. But at the moment, we are completely relying on, or to a very large extent, relying on public funding. As I mentioned in the introduction, we have increased the CO2 and emission taxes in Denmark. And then with the other hand, we have allocated funding schemes for CCS. We concluded 2 out of 3 funds. I think Jan will share a little bit of details on some of the concrete projects later. So here I'll just leave you with a bit of the setup on it. All 3 funding schemes are based on some sort of contract for difference. They only get subsidy per ton CO2 captured and stored, so there's no capex up front, but it's basically a subsidy that is based on once they deliver or document to the Danish state. I would say they're not delivering the credits or the carbon to us as the Danish state, but once they document that they have captured and stored CO2, they get a subsidy. And we have 1 contract with Ørsted and 3 contracts with the biogas companies that are mentioned here. Last tenders, the CCS fund is ongoing at the moment, where we had a pre-qualification deadline last month, and 16 companies applied for pre-qualification. 10 will be selected, and then the first indicative offer will be handed in August. In terms of CO2 storage, as I mentioned, the subsoil in Denmark is quite adequate for CO2 storage. We have some oil and gas production in the western part of the North Sea. See a map there of Denmark with some dots on. The blue stuff in the left part is part of the North Sea, where we have 3 exploration licenses awarded in 2023. And then we have actually 4 more licenses onshore in Denmark. I see that the map is slightly out of date because the one in the middle of the peninsula Jylland is actually now awarded just a few weeks ago before Easter for a company with a license there. So we have a lot of activities ongoing for exploration in Denmark. They are all in the exploration phase, I would say. Although we have received the first application for an actual CO2 storage project. It's called Green Sand, and it's one of the projects that are in the North Sea. They also in December published that they have taken investment decision on that project. I would say in this concern that there's no sort of a specific state aid to the storage part, and we are not sort of interfering with the commercial setup of how we run these licenses or how the companies want to store CO2. Obviously, there's a lot of public engagement involved in this, especially on the onshore sites, which are some of them in places where there are villages and people living on top. And so we have a lot of public engagement, and the companies that have the rights in these areas have a lot of public engagement. But so far it's working good, and we have a lot of data collection and a lot of activities ongoing. I would say a little bit about what the future outlook looks like in Denmark in terms of the regulation and other aspects that are related. We for sure have some regulations that needs to be polished or adapted a little bit, and the sort of the stars that we align for is only do what is required. Make sure that we have sort of timely implementation to the extent possible, and then there's always a balance in terms of what is it that we as the Danish state can take the risk, and what is actually better carried at other institutions, let it be the European Union or maybe on a sort of a company scale on a different aspect, and that has to be across the CCS value chain. Other themes that we are looking at now is a lot about the infrastructure, a lot about how we implement some of the EU regulation that are related to CCS. So a lot of exciting work ongoing, and hopefully we will have, and I'm quite certain that we will have the first projects, full-scale projects up and running, if not this year, then next year, and a lot more coming on stream as we approach 2030, which is a major milestone in the Danish greenhouse gas emission ambitions. So I think with that, I hope that I've given you a flavor of what is the status of CCS from the regulatory point of view, and some of this more implementation point of view in Denmark, seen from the Danish Energy Agency. So I will stop sharing the screen now, Karina, and swap back. Yeah.
Thank you very much, Henrik. So we just have another 8 minutes of your time. So we have a question in the Q&A, and if there are more questions, you can type them in while Henrik answers this one. The question is, did you have different conditions to apply in the 3 different funding rounds for CO2 capture? The winners were very different in the first and second round.
The short answer is yes, we did. The first one was very much focused on big emitters. So there, for example, the minimum quantity you had to guarantee for was 400,000 tons of CO2 per year. The second one, called the INNO-CCUS, was targeted at CDR, or what we call the negative emissions at that point. So and had no lower threshold. So there it was targeted smaller emitters, especially the biogas companies in Denmark. So yes, and it was biogas companies who was awarded the contracts in the next. So yeah, the last one is more different and open to everybody, to a very large extent at least.
With a much bigger sum of available funds.
Oh yeah. Oh
yes.
Yeah.
So we have 2 questions that I think we can pull together on infrastructure. One is, could you say something about the scope of the executive order on
the safety of
pipeline infrastructure, and the other is if there's a national strategic infrastructure plan to support longer term planning?
Yeah, very good questions. Thank you for that. So no, there's no sort of a national strategic plan for infrastructure in Denmark. We have taken the approach that it's very much up to the market to decide where and how the infrastructure has to be established. And it can be actually private companies, but also public entities that can do that. So hence, there's no sort of national plan for that infrastructure. In terms of the executive order, it's I had said we have this act on pipeline, which states that we can do an executive order for safety. So it's basically to ensure that we have sort of the legal tools as the DEA to set the requirements for the pipeline design. Actually, also something about the routing of it, the placement to ensure adequate use of resources. So that's what we're trying to look at now, and obviously we are looking a lot to the guidelines from the EU directive on that.
Great, thank you, Henrik. So we have a few more questions coming in. The first one here is, how would you describe the support for CCUS politically in general? Is there general multi-party support for CCUS, or are there risks for political swings?
Again, a very good question. I think one of the reasons that we in Denmark have been able to sort of move with a considerable pace is that we have a very broad political backup for this. So despite the fact that we have had elections over the last 5 years, basically all parties in the Danish parliament are supporting of CCS. So we are not discussing a lot about the direction from a political side of view. It's more the implementation. So there's a very broad political consensus on CCS.
You're being very humble to call it the what did you call it, about I mean, so when I travel, I get the praise that belongs to you, Henrik, because Denmark has really accelerated in these 5 years. So I think it's also worth to acknowledge the work that you have done. I'll just steal another few minutes of your time for questions. The next one is about the licenses. Onshore licenses stop at the coastline. Is there any plans on combined onshore-offshore licenses subject to the subsurface structures?
Yeah, to a certain degree, yes. It's a good spot, and I would say that it's the inshore licenses that are cut at the coastline, and it basically has to do with the Helsinki Convention, which is covering the Baltics and the Danish inland waters, which at the moment at least classify CO2 storage in the subsoil as dumping of waste in the marine environment. And there are hence at the moment the licenses are bordered on that. And there are clever people working on if storage in the subsoil a kilometer below seabed is actually dumping marine waste. So we'll see how that ends. It's obviously a bit complicated since part of the Helsinki Convention is Russia, and we are not really in sort of a political environment where we are doing a lot of work with them.
Yes, the world is indeed changing these times.
Yeah.
So we'll take the last question. I have more questions in the Q&A, so if your questions is not answered, I'm sure Henrik will be glad to respond via email at a later stage. The last question we have time for is, how do you align storage security with EU directive? Is that zero leakage or for minimal leakage?
I might be answering the question in a wrong way, but basically the fundamental approach we have at the moment in the DEA is that the CO2 and the design of the storage locations should be that the CO2 stays there, and at the highest possible reasoning develop elements that make sure it stays there, and that it doesn't matter if it's onshore or offshore. And that's part of the sort of approval process that we have. I would also say we don't have a lot of experience in approving the actual injection projects yet. So some of the elements and the definitions of, I think as the question is raised on, probably still to be clarified. But that basically we work on the assumption that there should be no leakage. But obviously we also know that we are working with uncertainties in the subsoil. So it's also about minimizing risk for that. So I think that would be my answer to that. And then just to follow up on your first element, Karina, sorry I have to leave. It's been a pleasure. And if you are having any questions, then please forward them to me afterwards, or else Karina and Jan are also very knowledgeable about the Danish CCS stuff. So we thank you for the questions and the opportunity to be here.
Thank you, Henrik, for finding the time to tell us about the policy and regulations. So we'll say goodbye to you, and then I will take over to give you insights on the research and innovation side of things, which are also needed to make this happen towards 2030 and 2050. So I hope you are able to see my slides. So as I mentioned, I'm the director of INNO-CCUS. We are a mission-driven partnership, and we focus on capture, utilization, and storage of CO2, both the technical and biological solutions. So I will start by giving you a bit of background, since INNO-CCUS is a rather new structure. We were established in 2022. So on the left-hand side of this image, you see the Green Research Strategy from 2020. It's a political decision made by the Danish government to accelerate the green transition in research and innovation. So they wrote the Green Research Strategy. They funded 4 mission-driven partnerships, as you see on the right side. One working on CCUS, which became INNO-CCUS in 22. Another working on green fuels. Another working on agriculture and food production. And then lastly, also a mission on circular economy. So all these missions were established in 2022. So we are now 3 years in operation. And in 2024, which is the second publication you see, the current government, they established that they still consider these partnerships important, and that we should maintain operations and strengthen the progress we have established already. So for us, it's a real boost to know that we have the support we need to accelerate the solutions. So we have an operating model which is also sometimes a bit complex, so I'll try to give you some insight here as well. We receive funding through the Danish Innovation Fund, and they receive funding from the Danish Finance Act. So on the top circle here, you see annual Finance Act funds. Each year they are set aside for the Danish Innovation Fund. And then it's a cascade funding mechanism from the Danish Innovation Fund to the mission-driven partnerships, where INNO-CCUS is one of them. So we actually apply for our funding at Innovation Fund Denmark. We get a pool of funds that we can then distribute for the projects we find mostly important, and also to establish and maintain the mission-driven partnership. That's really important to drive this forward. So we're not a foundation, we're not a project in itself, we are not a research center, we're not an NGO, but we are something in between that both supports projects and make sure that we can establish and maintain and develop an ecosystem. So when I say that we're a mission-driven partnership, it means that we have a clear and ambitious goal. It means that we are focused on collaboration and partnerships. It also means that we make portfolio-based decisions and we have a focus on societal impact. So you probably hear the term mission-driven in a lot of different settings. It's becoming very popular and it's something that is being interpreted in very different ways. So we have spent a lot of time understanding what does it mean for us, for our organization, in our context to be mission-driven, and how do we work in a mission-driven way to meet our goals, since the goals are more important than the method, but it's the right method to get us there. So I will take you through some of these processes we have. First of all, when you want to be mission-driven, you need to have a roadmap. And we have our own take of how we consider making a roadmap. So we published this roadmap in 2024. It's the second edition of our roadmap. And it's based on broad stakeholder involvement and technology mapping. It draws on existing scenarios rather than points out new scenarios. So we have the technologies mapped, we have the forecast of technologies, and then we look at the existing scenarios, for example, from Henrik from the Danish Energy Agency, and we identify the needs to achieve these scenarios. So we can point towards the areas that we need to focus on in research and innovation now in order to have the solutions in 2040, 2045, 2050 to achieve the scenarios. And this is of course dynamic. So we have the roadmap now, it's 1 year old. And when we see that it's no longer a useful tool, we will update it to reflect a new reality. So this is also very important when you work mission driven, that you adapt to the reality that you're in. So the roadmap, it's a comprehensive document, almost 100 pages. It's, I think, a very good night reading. Don't take it everything in one chunk, but I think the key messages are also really important to highlight, and it's the ones you see highlighted here. So we focus on these when we set our strategy and define the projects for the next round of funding. So I'll just go through them so you understand how we prioritize. First of all, we recognize that capture and storage from point sources, they play a crucial role in achieving Denmark's climate goals. So we consider this as a fundamental way of achieving climate neutrality in Denmark. We also acknowledge that the effective capture of point sources requires research into targeted capture technologies. So the same technology won't be the most optimal one for the different types of sources, and we need to understand how to match source and technology to get the best solution. We also recognize that there is a significant untapped potential in geological storage in Denmark. We can store around 500 years of our own emissions at current level. Some estimates are even higher. So we will happily borrow our underground to import foreign CO2 so we can solve the climate crisis in Denmark and beyond our borders. But we need to make sure that we understand the Danish underground and that we actually mature the fields needed to store the CO2. We also acknowledge that more research is needed in the utilization of CO2 if it will play a role in 2050. So when you look at the scenarios from the Danish Energy Agency and when you look at the scenarios from IEA and so on, you can see that utilization doesn't play any significant role in 2030. But when you look ahead, it will play a larger role towards 2050. There's no government strategy for utilization right now. And that means we have an even bigger task in making sure we support the solutions that are maybe at a lower technology level at this point. So we mature them so they are ready when we need them for the future. We also acknowledge that international collaboration on direct air capture should be strengthened to assess the potential in Denmark. Direct air capture plays a role in all scenarios for 2050. It's the only way that we can achieve the last few decimals of neutrality or even climate negativity as we are actually aiming for in 2050. So we need to get atmospheric CO2 withdrawn from the air, and that requires direct air capture or similar technologies. It's also an area which is not very mature in Danish research and innovation. It's not very big. So we acknowledge that we need to bring in knowledge and probably technology from other areas of the world to strengthen this position. We also acknowledge that biochar from pyrolysis can deliver a solid level of 1.5 to 2 million tons each year by 2050. And it requires, of course, that we scale and develop this application. There's a lot of barriers in all of these areas, and this is what we should address through research and innovation. So when I say that our roadmap is structured to drive decisions, this is what I mean. We have mapped the technology. So for each chapter, you will see a long list of relevant technologies for the area that you're looking at. Then we have assessed the maturity of the technology, and we try to forecast this as good as we can. And of course, as the closer we get to maturity, the better the forecast will be. We use this to define an innovation demand, which then shapes our strategy and the projects we fund. And we then take this and maps it against the technical reduction potentials and the 2030-2050 scenarios. So I hope this makes sense to you, that we, have bottom up from the technology and top down from the 2050 scenarios. So when we look at collaboration and partnerships, we of course define a lot of this through our projects. Right now we have 30 projects supported via INNO-CCUS. They go across the CCUS value chain for 7 projects for chemical CO2 capture. We have 5 projects on biological capture and storage of CO2. We have 10 projects on geological storage, 3 on CO2 utilization. And then we also have 5 projects on society and systems analysis. So they deal with all the aspects of CCUS that is not addressed through technology, basically. And just to give you an idea of what a project can look like. So all 30 projects are presented on our website, so you can see the description and some of the early results from there. But here are 3 examples just to give you some understanding of the type of work that we support. So on the left, you see a picture from Aalborg Portland, which is the largest CO2 emitter in Denmark. They produce cement. And you see a white tent in the bottom, and then you see these 2 pillars. That's the pilot plant for CO2 capture, which was installed for a little less than a year at Aalborg Portland to test how the energy can be utilized more efficiently in an amine capture process. So they learned a lot from doing this project, and it has paved the way for Aalborg Portland to receive funding from the EU Innovation Fund to go full scale in 2030. On the top right-hand side, you see an image from a university test field site where they're testing different biochar compositions. So the point of the project is to assess the climate potential of biochar in a Danish context. So they understand the different compositions of biochar, and they assess, the stability and the, what happens when you put the biochar into the soil. Are there positive effects that should be considered? But they also consider some of the regulatory aspects of biochar, since right now working with biochar means you have to get one permit for one field for 1 year. So it's very heavy, and they try to consider how can we work with the regulation to make it more smooth. On the bottom right, you see an image of a place in Denmark called Stenlille, which is currently a gas storage facility, and they are trying to develop a CO2 onshore storage site as well. So they have done a lot of the early work, and they have supported the monitoring and safety development, the technologies needed to have secure and safe CO2 storage. So they don't currently have a license to actually store CO2, but because they have the experience from the gas storage side, they have played an important role in developing these technologies. So this is just 3 out of 30 projects going on in INNO-CCUS. We also take a role in representing Denmark and representing the ecosystem and enabling synergies. And these are just 2 examples of how we do this. Denmark has recently become a member of the Excel ERIC platform, which is a platform for sharing CCUS research infrastructure. And Denmark is also a member of IEA-GHG, which is a technology program under the IEA focusing on CCUS. And both of these memberships are anchored in CCUS, in INNO-CCUS. So by taking on some of these roles, we can also coordinate the efforts in the ecosystem. I think it's really important that we have one anchor point for these functions. When we go a step forward, I mentioned that to work mission-driven, we need to make portfolio-based decisions. We've mapped all the projects in Denmark working on CCUS and published this state of CCUS with more than 100 projects in it. And we have just updated it actually this week. So we now have first edition from 23 and an updated edition from this week with 50 new projects that has joined in the last 12, 18 months. So I think it's quite impressive, and it shows that the field is really moving forward. We use this to inform our decision making. So whenever the board has to support new projects, they look in this publication to understand where can we actually make a difference. So I can see time is running a bit fast, so I'll make sure that Jan also gets his time to speak. We use State of CCUS and Direction 2050, the roadmap, to inform each other. So they have a codependency, and this is really important for how we operate in INNO-CCUS. And we use it to define the priorities of each project call that we announce. So speaking of project calls, we actually have 2 calls open right now. So if you're a researcher interested in collaborating with Danish entities on CCUS, you might be a bit busy because the deadline is May 28. But we also expect to launch another call late 25 or early 2026. So each of them has a specific strategic priority. So it's important to orient yourself if it's something you're interested in. My final slide is just this one where I want to mention that the reason we prioritize is because we are established to accelerate this field. And you cannot accelerate without prioritize. So that's why we have these principles that we are guided by the strategic priorities. We have portfolio-based funding. We align our activities with our roadmap, and we make sure that we have our focus where it matters the most for the kind of organization that we are. So that is everything I want to say, and I'll hand over now to Jan, and we'll take all the questions at the end of this session. Thank you so much for listening.
Hello, everyone. My name is Jan Boyesen. I'm the Market Director for CCUS at the Danish Technological Institute, and I will be giving an overview of the implementation of CCS in Denmark. And as Henrik also was telling, of course, what is driving it right now is that we have the CCS fund in Denmark. Ørsted received the first billion euros for their project, which I will present in a short while. But right now we have 4 billion euros more that are out there for tendering. And you see a lot of point sources applying for this funding. And you can say on top of these 5 billion euros, you will probably see a similar amount of funding coming in from the companies themselves. Maybe it's worth mentioning that what is actually supported in Denmark is when you store CO2 in the underground. So for each ton of CO2 you store, you will get a support from the government. That can be combined with credits like CDR credits if you have some type of negative emissions, and it can also be combined with a ETS system if you're more in the black space. And combining these two will actually create a more or less cover your costs and create the business. What has been also driving it essentially in Denmark is that the Danish government has a 70% reduction target, and they've been looking into the toolbox and figure out that even though they did a lot of other things, or we do a lot of other things in Denmark, we will still be short of about 3 million tons per year of CO2 reductions. And here, essentially, BECCS and cutting emissions on hard to abate industries will be needed in order to comply with that. So I said I'm the market director. Essentially, the Danish Technological Institute supports the development and implementation of technology. And of course, when we see the very ambitious timelines that we have here in Denmark, there are a lot of technical challenges that we are aiming at. And essentially, we want to reduce the risk of the technology. We also want to improve the performance, for instance, of carbon capture in order to keep the OPEX low. And then we also want to help our customers to select the right technology. And these are some of the things that we are working on. We are, I can say, also an independent research and technology organization. So as said, the first project that won the CCS pool was Ørsted, which will be implementing CCS. And they have this project will be in operation by early next year. And what they're going to do is that they're going to catch CO2 from two sites on the island of Zealand, one that is running on wood chips and another that is running on straw to produce energy. And they have purchased 5 modules of this SLB Capturi system as carbon capture. So it's a amine-based technology. Then they will be, on one of the plants, they will be trucking the CO2 to Kalundborg, from where they are constructing an intermediate storage site. And from there, they will transport it, of course, as liquid CO2 to Norway. The Northern Lights project, where they will inject it into the underground. So in that sense, it's a collaboration between Denmark and Norway. Apart from these companies, you will also see that Microsoft is among the partners in this project. And the reason for that is that Microsoft has purchased some of the credits that come out of this project. Since it's a BECCS, it's negative emissions, and Microsoft has entered that. So they're really a strong partnership here as well. So you can see some money coming from the Danish government and some money coming out of private companies. Actually, it's going, here you can see some of the pictures from Asnesværket in Kalundborg, where they are very soon completing all the physical installations. So you can see the storage tanks there, also the capture towers, and soon they will also start on the other aspect. But they're more or less now finalizing the last parts. So this is on the Kalundborg side, and then of course the CO2 will be shipped to Norway. The first ship has already been delivered. You can see the carrier there, as well as the receiving facility. And you can also on this picture see the future facilities, since the Northern Lights project decided that they will scale their capacity from 1.5 million tons per year to 5 million tons per year. So they are also supporting that. So this is the first project. Now, what we also see is that there are 4 billion euros more out there. And as Henrik said, there are 16 projects that have applied pre-qualification funding. And you can see the logos of some of those companies that publicly have announced that they are applying. Of course, we don't know all of them, but what will happen now is that it will be shorted to 10 projects that will send an indicative offer here by this summer. And then there will be additional kind of a process of applying for your project. So of course you need to have a full value chain. So you both need to have the point source as well as the capture, the transport, and the storage all completed for your project to be able to fly. What we have been seeing is that there is a lot of companies like big players like E.ON, Linde, and so on that are very focused and on creating and entering the Danish market because they expect to have experience here that could be commercialized in other countries. And that's of course very positive. I think the government was quite happy that we saw so many applications. And one of the interesting things is that there is a lot of waste to energy. Of course, we combust a lot of waste in Denmark. And that's one of the point sources that are applying a lot for this. And we expect the kind of the final bids to be sent by the end of this year. Then we will know who has filed in a full proposal, and by I think it's May next year, they will also start spending money on these projects. Another project that has received a big grant from EU Innovation Fund is Aalborg Portland, the cement factory. They're going for a pressure swing absorption combined with cryogenic carbon capture. So very interesting project there as well. They have, I think they plan to capture 1.4 million tons per year. And then a very interesting project that actually will probably come before the other one is the Green Sands project, which will start storing CO2 by the end of this year, beginning of next year. And this is CO2 from biogenic sources, so it's biogas upgrading. They receive a fund from the Danish government, and then you also get negative credits there. They have it's INNO-CCUS, the company that is operating an old oil site, I think it is, or gas, I don't remember actually, but they will start storing there. They have retrofitted a bulk carrier to be able to sail from Esbjerg out to Greensands project, and this will be a ship to platform operation. In the future, there might also be a gas pipeline that can be used for projects out in the North Sea, but for the current, it's going to be shipped to ship operations. This project can handle up to 400,000 tons per year, and it will start, as said, by the end of this year, most likely. So really interesting to see that it's actually taking off. And then you can see that one of the interesting things here is that biogas has really grown a lot in Denmark, and we have seen that a lot of these companies go from being kind of small agricultural based to be very capital intensive large companies that want to scale and mass produce these biogas plants. So here you can see an overview of how much CO2 and biogas that is actually being produced. So we expect to have about 600,000 tons per year of CO2 that is already being captured, since you do that anyway. So that's kind of a low-hanging fruit for CCS to kickstart. Then in terms of storage, of course, as said already, Denmark has a super nice geology to do storage, and therefore the government has looked into doing that. You can say one of the funny things here is that we are looking into offshore storage, but also onshore storage. And the reason for that is because it's expected to be way cheaper. So 7 licenses have already been granted offshore and onshore, and 3 licenses are more coming up. So we do have a lot of sites that will be in operation, hopefully. And here you can see the companies that have applied for those. One of the other interesting aspects is that the government has said that in order to finance the cost of the infrastructure and the site development, we will also store CO2 from other countries here as well. But one of the challenges in this aspect, of course, is the need for infrastructure to connect the point sources and the storage sites. So a lot of work to be done there. We need, of course, to define the standard specifications, also the dimensioning of the pipelines, as well as where they physically should be located. As Henrik also said, the concept has been that it's up to the market to decide where the infrastructure should be. So there is no publicly ownership or funding for infrastructure. It's entirely up to the companies to decide themselves where this should be going to and from. So it will be interesting when we see the tenders to the CCS pool, what type of infrastructure they are looking at. But I expect a lot of focus on infrastructure as well. And then finally, a little bit on what we are focusing on. We're working a lot on carbon capture, in energy efficiency, in improvement of the solvents, as well as monitoring the onshore and offshore sites, and then metering materials and so on. So these are some of the technical challenges that we see right now to help implement and scale the technology. And if you're interested in learning more about Denmark and the companies working on CCS, you can go into our website where we have an online overview of projects and companies and so on. And I think we're running short on time, so I'll not go through all of this because I already presented my conclusions during the way. But in general, you can say we have had a super accelerated development. So, Karina, I will hand the word to you.
Thank you, Jan, for a very good overview of what is actually going on in Denmark right now. So we have a few questions in the Q&A, and we don't have time for all of them. So we'll take a speedy answering session the next 3-4 minutes so we can end on time. First one is for me, clarify research into targeted capture technologies. What does it mean for capture of point sources? And the asker says, I would argue that in a climate emergency, we don't need more research into new technologies for point sources. We need to get on with deploying what we have, and that research must focus on improving what is available for deployment today. So I agree with this question that we should employ or deploy what we already have, but we also have to make sure that the deployment is viable. So when I say targeted research, I mean matching the right technology to the right point source, so we don't put the point source owner in a lock-in of technology that is not viable for the future. So that's the very short answer on this one. The next question, and here maybe you can help me, Jan, what role has Microsoft played? They seem to have taken a very active role in the design of the CDR market, as opposed to simply acting as a purchaser of credits. I know that Microsoft and Ørsted, they have partnered closely on this, and they have addressed a lot of the issues that were not solved for them to make the deal. Maybe you have some details on the process.
No, I actually agree. So it's a bilateral agreement. Microsoft has been very active in developing that. And I think what they have spent a lot of time is kind of on the accounting of the credits and so on. So I think they have actually spent a lot of time on all these type of issues. So it's not just the technical side, but it's also the trading and accounting, which Microsoft is also very interested in.
Yes, perfect. So the next question is something that I am not able to answer. I'm not a geologist. The question is, how is pressure built up factored into your estimates of aquifer storage potential? If you don't have the ability to answer that, Henrik.
No, I'm not a geologist either, but I know that they have quite extensive modeling, and at the end of the day, they also want to operate. That's why you get an exploration license. So, of course, one thing is your model, but at the end of the day, you will also like to have some testing of it.
Yes. So let's take the last question. The 600 kiloton of bio-CO2 from biogas upgrading, is that mostly farming, and how many nodes or cooperative collectives for the biogas will there be? Is it dispersed over many farms?
Yes, it is dispersed over many farms. We have seen a massive increase in the amount. And of course, the biogas reactors are also increasingly large in size. So it's less than 100, I know. I think it's maybe 70, 80 sites. I don't remember exactly the amount, but yes.
Okay, perfect. So we want to end on time, and I promised Mel from UK CCS-RC to get the last word. I just want to thank all of you for joining us today, and thank you for listening to our presentations. And thank you, UK CCS-RC, for organizing this whole webinar series. I think it's very helpful to share knowledge and understand the development in each country. So
Absolutely.
Mel, you can
yes,
take the
thank you.
word.
Thank you, Karina. And I'd like to add my thanks to you and to Jan and to Henrik. It's been a fascinating webinar. As you can see, the next webinar will be CCUS in Poland, which is in 3 weeks on the 22nd of May at the same time. And also just to say that there are a number of questions that our speakers at the UK webinar last time didn't have time to answer, but they very kindly put them together in a document which is now available on the web page. So yes, thank you for joining us today, and hopefully see you next time.